In this video, we're going to cover chapter one, and we're not going to cover it in its entirety. Specifically, we're going to look at some important definitions in this video here. So let's go ahead and go to the next slide here. So, a lot of what we're going to be doing in statistics is we want to study a population. But oftentimes it's too hard to study the entire population. And so instead, we'll study a smaller group, which we'll call a sample. Now, we do want to be careful about how we draw this sample. We want to make sure that we do it randomly. We want every person in the population to have an equal opportunity to be selected. This helps ensure that our sample is representative of our population. All right. And so we'll actually use different notation. For instance, when we talk about the mean of the sample versus the mean of a population, or if we're talking about what proportion of the population maybe has a certain quality, we'll use a different notation for that versus the sample. Okay. And so, an easy example that we could think of here where we will be maybe drawing a sample is if we just think about maybe presidential polls, right? They don't actually survey everyone in, say, the US. Instead, they take samples. It's a lot cheaper to study a subset of the population rather than the entire population. And it's just much more feasible when we have these large populations. All right. And so I actually have the definitions written out here for us. But you can see that there's two new definitions on here. So let's just think about the average for a second, which most of the time in this class, we're actually going to call it the mean. And I'm going to tell you that you can use those words interchangeably. There is a subtle difference between average and mean, but it's not going to get in the way of your understanding of the course. Okay. But if we are talking about the average, okay, or the mean of a population, okay, we call that a parameter. However, if we're measuring that same thing, again, the average or the mean, but for a sample, we'll call it a statistic. And there's going to be really several different statistics and parameters that we're going to look at this quarter. Let's go ahead and see what those are. Okay. So first of all, we have measures of center. So these are ways in which we try to identify literally the middle of the data set. Okay. And in certain situations, we want to use one versus the other, and we'll talk about that as we go. But you've probably actually seen or have seen all of these measures of center: the mean, the median, and the mode. Okay. This picture here is just a picture here to add to the slide. This is something we'll talk about later on, but essentially is what this image does show here, is that the mean typically gets pulled into the tail of the distribution. Okay, but again, we'll talk about that more later. Measures of spread. So not only do we want to try to locate the middle of our data set, sometimes we want to know how spread out is the data in our data set. Right? And so we have a few different ways of measuring that. The one that we're really going to use the most this quarter is going to be the standard deviation out of all those. Okay. But we will talk about the variance briefly, the interquartile range, and the range. Okay. All right. And then others, these ones that are under the others category are not less important or more important. They just don't fit these two categories that I've listed here. Okay. So towards the end of the quarter, two statistics that we're going to talk about a lot, and I guess I should say parameters, will be means or averages and proportions. And I want you to just think about a proportion as the decimal representation of your percentages. Yeah. All right, well, let's go ahead and take a look at our next slide here. Okay, so we're going to try to identify maybe the population or the sample here. Let's see what this says here. So each month, the Gallup organization conducts a poll for CNN and USA Today of the US president's current popularity rating amongst Americans. For a poll conducted March 21st through 23rd, 2005, of 1,001 Americans, it was reported 45% of people polled said they approved of how Bush is handling the presidency. The margin of error is plus or minus 3 percentage points. All right, so let's go ahead and see what our first question is here. All right, so the first thing we want to try and do is identify the sample. Okay, so the sample here is simply the people that we have either included in our experiment or our survey or study, whatever that might be. Okay, and so here we've included these 1,001 Americans to be part of our sample. Okay. Right now, for the population, the hope is, and it's not always the case, but if we're really careful, the hope is that the sample will be representative of the population. Okay. And so, is what we're really looking for here, right, is the US president's current popularity rating amongst Americans. Okay. So, our population is just Americans. Right. And when we are working through story problems later in the quarter or looking at real life examples of studies, surveys, experiments, a lot of times the word all will come before whatever your population is. And that's just to emphasize that we are talking about the population, the entire group. All right. And then next here, it asks, is the 45% reported a statistic or a parameter? So is what we need to ask ourselves is, did that 45%, did it come from the population or did it come from a sample? Okay. And well, that 45% came from the 1,001 people surveyed. Those were the people in our sample. So this 45%, we will actually call it a statistic. Okay. Had we surveyed all Americans and came up with the percentage of people that said that they approved of how Bush was handling the presidency, we would call that the parameter. Okay. But we didn't do that. Okay. All right. And then the last part here, I just want to emphasize this. Um, when I say the word proportion, because we will use it a fair amount this quarter, all I mean is take your percentage and write it in its decimal form. Okay. There's a good reason for this. We will see that when we actually talk about probabilities later on in the quarter, we always think about them as numbers between 0 and 1. Okay. So we will do a lot of converting back and forth between the percentage and the corresponding um, proportion, okay, or decimal form. Okay. And so, as what I've written down here is 3 ways we could express this 45% as a proportion. So the most obvious way is just writing it as 0.45. Okay. Right? If you just divide a percentage by 100, you'll get the decimal form. Okay. And so over here, I've also written it as a fraction. I'm not going to be pickier or not about whether you reduce your fractions here when we're talking about proportions or probabilities. But that 45 out of 100, I could write that as 9 out of 20. And so these are all acceptable ways to write proportions. If you plug any of these 3 into your calculator, they all give you a number between 0 and 1. And specifically, they all give you 0.45. Okay. All right. So this slide here um, is not one that we'll talk about for a super long time. We're not going to talk a lot about um, what a census is, but we're going to do it briefly here. So, is what I have here on the right is actually data from the U.S. Census over the years, and this is specifically for Seattle. Um, And is what I'm trying to emphasize really with this slide is that we rarely take or yeah, we rarely will actually perform a census. It takes a lot of money and time. Okay. And you can actually see here at the bottom it says U.S. Um, right. It's saying down here at the very bottom that they're performing the census every 10 years. Okay. So we're only counting how many people are in the country every 10 years. And part of this is a process that takes a long time, costs a lot of money, and involves a lot of people. Okay. And even the US Census, even though it's done only every 10 years, it's still far from perfect. And right, the US population changes every day with births and deaths occurring every day. So most of the time we won't be doing this. That a census would be an example of trying to actually study the entire population um, as opposed to looking at a sample. And then we have a few more definitions here: individuals, variables, and observations. Okay. So, an individual is just simply either a person, okay, an animal, a plant, a thing. And so I've listed a few examples down here, but these are essentially the individuals or objects involved in our study. Okay, up there it says in our data set. Um, but yeah, we could be talking about just college freshmen. Okay. That would be, or a single freshman would be an individual if we were studying all freshmen, say for some college. Okay. Again, a single newborn out of a bunch of newborns would be an individual in some study, maybe on newborns. Okay. Let's look at variable. Okay. So, a variable, it says here, is any property that characterizes an individual and it can take on different values for different individuals. Okay. So again, maybe we're studying college freshmen, and maybe one of the things we're trying to figure out is the average age. And so our variable that we would wind up studying as we're maybe surveying or maybe looking at a list of all freshmen at a college is we would be looking at the age here maybe as the variable. Yeah. But of course, we could study other variables if we're talking about college freshmen. We could talk about gender. Okay. Another variable that we could talk about is maybe intended major, or what high school they came from. Okay. So we keep listing variables on and on there. And then an observation is kind of, I think, a strange definition, but you will see that it's going to become a useful one when we start talking about probability. Okay. But I think the examples down here below are more clear than the definition itself. But let's take a look at both. So, an observation is a fact or figure we collect about a given variable. It can be expressed as a number or as a quality. Okay. So, when we say observation, we are literally talking about a single observation. So if we are studying maybe freshmen and we're curious about maybe their gender here, we might say a freshman is male. Okay, that would be considered one observation. Okay, um, or again, if we're talking about newborns, an observation would be that this one particular newborn that has been maybe randomly selected weighs 7 pounds. All right, let's go ahead and go on to our next slide here. So this right here is actually an Excel or a screenshot, I should say, of an Excel document here. And so is what's in here are actually a bunch of electric vehicles. And then we actually went through here and we have the acceleration time to go from 0 to 60. That's that column C here. Those are all that's the number of seconds it takes for these cars to go 0 to 60. We have their top speed in kilometers per hour. their range on a full charge in kilometers, how fast they charge in kilometers per hour, and their price in euros. Now, this is a fairly old data set, so some of these numbers are probably a little different now. Yeah. But let's go ahead and see what our first question is, which is, what are the individuals? And so one answer that I often will get here is, well, it's the model. Okay. But in actuality, the individuals are electric vehicles. Okay. I think that if you do look at this question and you answer, well, the models are the individuals, I think that's very close, because they do uniquely identify the cars in this data set. But the real answer here is the individuals are these electric vehicles. The model is actually a variable. And so we actually have lots of variables in this example. In fact, everything that's in the first row, so the brand, the model, acceleration time, top speed, range, charging speed, and the price in euros, these are all our variables. Okay. Right. And this is actually usually how data does come to us is oftentimes lots of data is collected and we only maybe need a little bit of it. Okay. And so again, maybe we're only interested in the acceleration time. And so maybe we really only care about columns A, B, and C. Okay. But as you'll kind of see as we're working through the course, oftentimes we'll kind of clean up these data sets and just give you the information you need. But yeah, a lot of times we have a lot of extra data. Now the question is, well, what is the data? Okay. So the data really here is just all the different values that the brand took, the model took, the acceleration, all those different accelerations, all those different top speeds. So basically, everything in this data set now, except for row one, everything in there is data. Okay. All right. And so you can see data can take on kind of different, or data can look very different. Sometimes it looks more descriptive, like the word Volkswagen. Okay. And sometimes it looks more like a measurement, like 4.7. Okay. And we're going to talk about that difference here in a second. Right here. Okay. So we actually have lots of different ways in which we can kind of classify or categorize our data. I'm only going to have us look at I think, four different ways. Okay. And now, two ways in which we can really, or two ways that we can describe our data here are quantitative or qualitative. And so if we actually go back, all of the ones in here that are numbers, and when I say this, I mean like 4.6, 10, 4.7, 6.8, 9.5, those are all actually quantitative versus the ones that look like descriptions are what we'll call qualitative or categorical. Okay. And so let's come back over here. Okay. So let's read what it says. So some quantity assessed or measured for each individual. We can then report the average of all individuals. Okay. So that second sentence there is there as a way to describe how you can test whether or not your variable is quantitative or qualitative. Okay. So if you can actually take an average of that data and it gives you something meaningful, it's going to be quantitative. Okay. And let's go see what qualitative is. Some characteristic describing each individual. We can then report the count or proportion of individuals with that characteristic. Okay. So notice it does not say that you can take the average here. And let's think about this. You can see some of the examples down here. Let's ignore area code for a second. We'll come back to that one. But you have blood type A, B, A, B, O. Okay. So these are just simply categories. Okay, right? You can't average the blood type. Okay. Similarly with flower color, white, yellow, red, etc. Um, you can't average those either. Okay. On the other hand, though, area code, these are numbers, but they're numbers that if you were to average them, wouldn't really give you anything meaningful. So, for instance, if we took the average area code for everyone in the class, would that give us anything useful? All right. And the answer is no. Okay. And so, some, but not very many, some of our categorical variables do involve numbers, but again, their average will not give you anything meaningful. And so, here's another good example. Um, we could take the jersey number for maybe every basketball player at Bellevue College. And if we were to average all of their numbers on their jerseys, that doesn't tell us anything about the team, okay, or the players. Okay. Right. And then quantitative up top, coming back to quantitative, these are always expressed with numbers. Okay. So right, you're if we're talking about age, we always describe that in years. Okay. We could be talking about blood pressure, right? That's going to be described using actually two numbers. Okay. And then leaf length. Okay. This is also going to maybe be measured in something like centimeters or inches, but the point is it's going to be a number. Okay. All right. So these are two big categories: quantitative, qualitative. Um, Now, I will sometimes use the word categorical rather than qualitative. That way, I don't want it to be confusing when we're trying to decide between quantitative and qualitative, and they just sound so similar that sometimes I prefer just to say categorical rather than qualitative. But another big reason for us looking at these two is there are certain types of graphics that we can make when our data is quantitative versus qualitative. Okay, so one of the things we'll see is for qualitative data, we really will only be looking at bar graphs, pie charts, and frequency tables. But when it comes to quantitative data, we can have dot plots, stem and leaf plots, histograms, okay, and we'll also have box plots. Okay, and then when we have multiple variables and they're quantitative, we'll have something we'll call a scatter plot. All right, let's go ahead and take a look at our next slide. So we want to determine whether the data in each one of these bullets is categorical or quantitative. So the first one says the political party affiliation, Democrat, Republican, or Independent, in a sample of 50 voters. So these are just categories. Um, we can't average political parties, okay, and at least and get something meaningful. Okay. And again, if you want to say qualitative instead of categorical, that's perfectly fine. Oop, I didn't mean to make that one pop up. This is the temperature at which each piece in a sample of 20 pieces of heat resistant plastic begins to melt. Okay. So here, this is going to be some amount of time. Okay. And it actually would be nice to know if we're maybe designing some product, might be nice to know the average amount of time it takes before this type of plastic begins to melt. And that average would give us absolutely something meaningful. Okay. So this will be quantitative. Okay. And then another one that kind of involves manufacturing, it looks like here. the defective status of each of 100 computer chips manufactured by Intel. So this is again categorical. It's defective or it's not. It's not going to be a number here. And then lastly, the current unemployment rate in each of the 50 states. So a few things here. One is this is going to be a number. Unemployment rate is usually going to be expressed as a percentage. Okay? But we also could find the average unemployment state for the 50 states. Okay. And that would give us something meaningful. So we have our quantitative. All right. And I got us another example here. And there's a couple interesting things to talk about here. But let's go ahead and read it. So it says a study examined the condition of deer after a particularly nasty winter. Sex and condition, good and poor, of a random sample of 61 deer are noted. Data from such a study could appear in either of these two formats. And so this is a very normal type of study. I don't know if every state has it, but I'm sure they do. At least our state is regularly trying to estimate the population of deer and elk and moose. That way we can make sure that we can keep those populations at a healthy level. Now, if we look at our data set here on the left, is what's trying to be expressed is the full data set. Okay. But you see the dot, dot, dot there, right? And so is what's going on is if we actually listed the full data set like in an Excel document, right, this would have 61 different individuals in it, and it'd be fairly lengthy. Okay. At least by our standards, it would be fairly lengthy. All right. Now, one way that we could make it a little bit easier to analyze the data is we could use what we call a frequency table, which you can see over here on the right. Okay. And so this is nice because it's just grouping together all the males that were in good condition, all the females in good condition, the males in poor condition, and the females in poor condition. Okay. Rather than now, because now we don't have to go through and count, how many males are in good condition, let's say. Okay. So one thing, yeah, frequency table helps us summarize our data. Just like our graphics that I was talking about a moment ago will also help us summarize our data. And those graphics, again, were things like bar graphs, pie charts, histograms, and so on. Okay. So, first of all, who and what are the individuals here? And so, the individuals in this study are just the deer. Okay. So yeah, each one of the deers is each one of the deer are an individual. Okay. And then what are the variables and are they quantitative or categorical? Okay. So this is where the next kind of interesting part happens. So a lot of people will answer that there are three variables. Okay. It actually ends up that there's only two, and the two variables are the sex of the deer and the condition. Okay. And so is what the deal is that third thing, count, right? We were not measuring the count of each individual deer. Okay. A variable is supposed to be something that is going to be used to describe an individual deer. Okay. Versus the count is a summary of many of the deer. Okay. In fact, we call it a summary statistic. Okay. You can see down here, I have the individual, the sex, and the condition are all categorical variables. Okay. So actually, I missed one. The individual itself is technically a variable as well. Okay. They each have their own corresponding number there, deer one, deer two, deer three. Just like with the electric vehicles, we had the different models. Okay. All right. But yeah, I want to get to that count. The count is not a variable, it's a summary statistic. And so what do we really mean by that when we say summary statistic? Well, we mean you can think about the count as almost like an average or a percentage or a proportion. The count is something that we computed based on the data. It's not something that the individual deer. It's not a quality of the deer. Right. And then the last thing I want us to do here is what are some examples of observations? Okay. And so I'll have a couple listed here, but if we just go back, we could say like the first deer or individual one was male. That would be an example of an observation. Okay. Or individual six was in good condition. Okay. That is what we are talking about when we say a single observation, things like that. Okay. All right, so I have one last thing here in this video that I want us to take a look at, and this is continuous versus discrete. And so, just like when we were talking about quantitative and qualitative variables, okay, in one case we had certain graphics we could make, and in the other case we had different graphics that we would be able to make. Well, when it comes to probability later on in the quarter, we'll do something very different when we're working with a continuous variable versus a discrete variable. Okay. Now, these two ideas are deeply connected mathematically, but this is going to be the connection between these is really going to be happening behind the scenes. So, what we do will look very different for both of these cases, but there actually is a deep underlying connection. Okay. But let's see what the difference is between the two. Okay. So, when we have a variable that's continuous, that means that it can take on any value within some range. Okay. And so, an example of this, a good example is the height of a tree. Okay. So, if we were to choose some specific tree species, there would be probably some known tallest height that type of tree has ever been measured. Okay. And now, if we were to randomly select a tree of this species, okay, um, it could take on any height as long as it's below whatever the maximum is. Okay. And so, is what I mean by that, by it can take on any height, as long as it's within the range of heights that that tree could take, is that the tree doesn't have to be exactly 2 meters tall or exactly 10 meters tall. Okay. A tree could be 1.765432 meters. Okay. It could take on some crazy decimal number for its height. On the other hand, when we're talking about discrete variables, you can actually count all the possibilities. And we won't have crazy decimals as options for our variable. Okay. For instance, number of home runs hit in one season. Okay. That right there is discrete. You can either have one home run or two home runs in a season, or three or four, up to um, some reasonable maximum there. Okay. And you can't have 3.2 home runs, right? Okay. If number of home runs was continuous, then we would have to be able to hit again 3.2 home runs or 3.7234 home runs. Okay. But when it came to that tree, it could be any crazy number between the minimum and maximum height. Okay. Now, there is a little bit of a subtlety here. It doesn't, when we say discrete, it can take on decimal numbers. It's just it can't take on every possible decimal number. Okay. And so an example of that is if we're actually talking about money or dollars. It's actually a discrete variable, but it can take on decimal numbers, but only to the second decimal place, right? When you go to the store, you're not going to buy something that is $21 and 33.5768 cents. Okay. All right. When we talk about dollars, we end at the second decimal place. So if we were talking about the cost of things at the grocery store, we could just simply list out all of those possibilities. Okay. Something could cost 1 cent or 2 cents or 3 cents or 4 cents, up to whatever the highest cost of something in the grocery store is. Okay. All right. And so this wraps up the first part of chapter 1, which means you can now go ahead and start the homework for definitions of data, or definitions and data. And if you have any questions as you're working through the homework, don't hesitate to post your question to the discussion board or send me a message.